All right, so if we go back and look at our ring openings of epoxides, so we can take an alkene, treat it with R, CO3H, and maybe R is methyl. We can make an epoxide. I'm going to draw these just kind of quickly. And we can open this up with acid and water. And that will give an anti-diol. That's what we did in that exact reaction in a previous video. We can open these up under basic conditions, and sodium hydroxide will often work for this. In this case, it's sodium hydroxide. The hydroxide will attack at the less highly substituted carbon, and we'll still get an anti-addition. Oops, let's take that back. Once we protonate things, we get this. I know the silent videos are really not very riveting, are they? So these are both anti-products. They're anti-diols, actually. Sometimes you want to get your diol, but you want your diol to be syn. In other words, we want to get something that looks like this. The two OHs are on the same face. Well, rest assured, don't worry about it, because there is a way to do that. There are two sets of reagents that accomplish that. One is KMnO4, that's potassium permanganate. And we normally do this in cold sodium hydroxide, cold dilute sodium hydroxide. And we won't go through this mechanism, but what we get are the two OHs added. Both things that we add end up on the same face, so this is a syn addition. That's one way to do it. I'd say the more modern way to do it is to take our alkene and treat it with osmium tetroxide, although osmium tetroxide is wicked toxic, crazy toxic. But it accomplishes the same thing as potassium permanganate. And we will again get the syn-diol. So these reactions both work really well, and they both complement the ring opening of epoxides, which tends to give us anti-diols.